Okay, so we're proceeding from the sixth question that we solved. This time around, we had a problem where we are trying to establish a relationship between age and mass. This information is relating to babies. We have 10 of them, and it looks like there's a shaded gray color covering the first six values that we have there. So those values have been plotted for us, revealing ours to finish off the outstanding ones. So we are being asked to complete this scatter diagram. The first 6 points have been plotted for us. What type of, okay, so we pick the type of correlation from the other points that we plot. Let's try and check. The next one is 9 for age, 4.6 points. 9 for age. So I'll make my pen 9 for age, then 4.6. And it looks like our 4.6 is here. So if these two lines intersect, now I have the points like there. I have my point. Let me try check the other points that I'm given. 7 and 4.5. So I have my 7 here and 4.5. Our find is exactly halfway in halfway. So that's 1, 2, 3, 4, 5. So it's 7 is the fifth value. The billing will be somewhere here. Then still proceeding. The next one, which is 1 and 2.5. 1 is here and 2.5 we find some way there. Then finally we have 11, 5.3. 11 is here and 5.3 we find somewhere. So where the two meets or intersects, 11 and 5.3, somewhere there. Then, if we look at the trend of these points that we've plotted, I think that will relate to the solution that we need there. They are saying what type of correlation is shown on the scatter diagram. When we are interested in the relation, there we try and come up with a line that equally separates the points that we plotted. That line, we call it the line of best fit. So when we try and look at the way those points are crowded, looks like they are following a slightly straight line slightly to the right, which will give us a positive correlation. So this type of correlation we call it positive. Then on the scatter diagram, we're being asked now to come up with a line of best fit. Now this is a line which will equally divide our points. So we will just try and split our points equally and we label it that this is our line of best fits. So normally we use this line to make predictions. Given one of the variables, we can try and estimate the other one. So use your line of best fit to find an estimate of the mass of a 14-week-old baby. 14 week. So this is how we use it. 14 weeks. Then you try and make this so that at least everything is clear. 14. This is where we have our 14. So we draw a vertical line. When we touch our line of best fit, we come this up. So it looks like 14 week old baby will be having a mass of approximately, so I can put approximate signs here, that it will be approximately 6.2 kilograms. That will be the rough estimate of the mass. So let's have a look at what we have on the next problem, which is number 8. Number 8, we are given a scale drawing which shows the positions of both A and both B. Now the scale is 1 centimeter represents 0.5 kilometers. So find out the distance between both A and both B. Now because I'm doing my calculations on the screen. Say for instance, I measured here and find out that my distance is 2.5 centimeters. Now, each centimeter is 0.5. Then what implies is that if we calculate the Rubik division, say 2.5, we divide it by 2, it will be giving us 1.25. So what it means is in kilometers, this distance is going to be 1.25 kilometers. All right, still proceeding. Let us L lies to the east of both A and B. Now, L is 4.4 kilometers from port A and 3.3 kilometers from port B. So we might be interested in finding out the actual distance on the paper, and given that each centimeter is 0.5 kilometers, then what about the distance of 4.4 kilometers? On the paper, how long will it be? So it's as good as I'm taking 4.4 and divided by 0.5. So I'll take 4.4 divided by 0.5, and the result will be 8.8. So we have 8.8 centimeters. That's L on both A. Then both B, we have a similar calculation where we are using X to say, well, X on the ground. Let's see. I want to erase again. And cut all this. I bring my pen again. We are saying doing the same calculation, 1 centimeter is 0.5 kilometers. So what about if we have 3.3 kilometers on the paper? How long will it be? So it's a similar calculation where we are taking 3.3 divided by 0.5, giving us, it looks like 6.6 there. Okay, that's what we're doing. So it means from L to D, that would be 6.6 centimeters. So what the argument here, we are now required to use a ruler and canvas forming and perform a construction to locate the position of L. So what we do is, if we open our canvas 8.8 centimeters, so on the sum of it, if we measure 8.8 centimeters, then we try and draw an arc. Then a similar process will be done for uh, for B, where we are going to open our canvas 6.6 centimeters, and we also try an arc. So where the two intersects, that's going to be our location for point L. I hope this explanation would suffice for this type of problems, because you need actual tools where you open and you do the measurements. So where the arcs cross, then that's the point where you expect to find that particular object. All right. Thank you.